Properties of metals. Let's start with solids. Solids are formed when the forces of attraction between particles in a substance are high as compared to the thermal energy of the substance. If the force of attraction is high and thermal energy is low, the particles remain close to each other and there's very little movement. So solids have a fixed mass, volume, and shape. They have the least space between particles compared to liquids and gases. They have fixed positions of particles. They are rigid and not compressible. Metals are solids at room temperature, except for mercury, which is a liquid. Metallic atoms lose electrons easily. The free electrons become delocalized. Instead of orbiting their specific nuclei, they move freely in a sea of electrons around the positively charged ions. So here's our atom, which is now ionized. The electron, it left it, and it moved over here. And then you have positive ions all over the place, and here's your negative electrons moving around. Metallic bonding involves an array of positively charged metal ions surrounded by loosely bound electrons. There are strong electrostatic forces between the ions and the free electrons. The bonding between the atoms form crystalline structures as shown below. And we have several different examples. Here's a cubic body centered, here's a cubic face centered, here's hexagonal. You don't have to memorize though, but hopefully you can see the patterns where the atoms are held together with very strong bonds between each other. The circles represent the atoms, and the blue lines represent strong bonds between the atoms. These structures are also known as lattices. Metals are identified by several physical properties that are determined by the crystalline structure and delocalized electrons in the metal. You have luster, which just means how shiny they are, their melting points, malleability, ductility, sonority, electrical conductivity, heat conductivity, and they are readily alloyed. That means they are able to form mixtures with other elements. And here's a very nice tutorial on the different properties of metals if you would like to click on it. The first property we'll talk about is luster. Pictured below is pyrite, a metal. Metals are shiny. This property is called luster. The free electrons on the metal's smooth surface reflect the incident light, so the metal appears shiny. Metals have high melting points as their atoms are strongly bonded to each other in crystalline structures. It takes a lot of energy to break the bonds, which requires high temperatures. Cast iron has a melting point of 1,204 degrees Celsius, or 2,200 degrees Fahrenheit. There's a wide range of melting points. Right, where's our little one here? Lead, and here's platinum, a very high melting point, etc. Malleable metals, when struck with a large enough force, will flatten into thin sheets. Gold, iron, aluminum, copper, silver, and lead are very malleable. The rows of ions within the crystalline structure of the metal will slide over other rows when struck with the force as shown here. So here's the external force, and the metal gets deformed. These atoms, these ions, move over, the others stay in place. And here's a piece of gold that's being struck with a hammer, and here it is as a thin sheet. Gold is the most malleable metal. Similar to malleability, the property of ductility is caused by rows of ions in the metal structure sliding over each other. But this time, the metals are stretched instead of being struck by a force. Ductile metals can be stretched without breaking or losing their strength. Copper, when stretched, is formed into electrical wires for circuits. Gold, platinum, and silver are the most ductile metals. So you would have the original wire here, you pull it through this little stronger piece of metal here, and it gets thinner. When struck with a force, the ions in the metal vibrate, creating a distinctive metallic ringing sound. Nonmetals do not have this property, so it's a good way to distinguish between metals and nonmetals. Because of that, metals make good bells. And you can click here to see some sonority tests. Metals are good conductors of electricity because the electrons are delocalized and relatively free to move. So we've got electrons drifting randomly around the lattice of nuclei. Wires in electric circuits are made up of conducting metals. When an electric force is applied by a battery or a power company, the free electrons will move in the direction of the force. This movement of charges is called a current. Metals are good conductors of heat. The lattice holds the positive ions close to each other, allowing them to transfer kinetic energy efficiently to other ions and the free electrons.